Okay, dear viewers. So today our topic will be properties of ionic compounds. Yesterday we studied about the ionic compounds. Now we will take their properties. So we'll start our topic. First of all, the first property that ionic compounds possess, as we know, they are made up of ions, and their first properties is that they are consisting or they consist of ions. They are containing ions or they are made up of ions. They possess ions in their structure. For example, we will take sodium chloride, NaCl. Actually, this NaCl is made up of the ions, that is sodium ion and that is chlorine ion. Okay, dear? So they are made up of ions. For example, this is sodium chloride. This is an ionic compound. This is also known as common salt. You are using it daily at your homes. It's used to make your feast tasty. So it is made up of sodium and chlorine, and they are not in the form of molecules, they are in the form of ions. You will find sodium ion, you will find chlorine ion in this compound. Okay, dear? So they are made up of ions. First property, that as we know, they are known as ionic compounds. So these ionic compounds, they are made up of ions. Now, second, the ionic compounds are usually solid at room temperature. So second property we are discussing, that is, they are solids at room temperature. Okay, I'm writing TMPT, temperature. So second property is that they are solids at room temperature, means at 25 degree. Normally room temperature remains around the 25 degree. So at 25 degree, you will find them solids. You will find them solids. Okay, dear? So why they are solids? What makes them solids? As you know, these substances are solids. Why they are solids? Because the force of attraction between the ions, which is known as electrostatic force. So electrostatic attraction, electrostatic attraction. Yeah, hum kahenge, or we can say force is strong. So the force between the ions is strong, and this force make these substances or these compounds solids. So what is the main force? That is the electrostatic force, which is making these compounds solid at the room temperature. So if somebody asks why they are solid at room temperature, the answer should be that these are ionic compounds. They are having ions in them, and ions are positively charged and negatively charged. And between these two charges, there exists a force that is known as electrostatic force, or we can say ionic force. So this force makes them solids. So usually we find them solids at the room temperature. Third property of these ionic compounds, that is, they are crystalline in nature. Or we can say these ionic compounds are crystalline. So we'll write here, property number 3, they are okay. Now we have to find why they are crystalline in nature. What makes them crystalline? Okay, dear. We know these are made up of actually ions. Okay, so we are taking once again for the example of sodium chloride. So this sodium chloride is actually formed of Na positive and Cl negative. Okay, dear. Now these are ions, and the ions have electrostatic force. You know, if there is a charge and there are surrounding charges, and those surrounding charges are negative in nature and positive in nature. For example, I'm having this sodium here. This sodium positive charge is surrounded by, say, chlorine here. This is negative charge. So this sodium, this positive charge will have affinity with the negative charge, not only with the one, that is NaCl, but other surrounding charges, that is negative charge. Say here it is negative charge. Here it is negative charge. Here it is negative charge. Okay, dear? The sodium is having affinity or electrostatic force upon the opposite charges. So that is negative charge, because itself it is positive. It will be having impact on the charges which are surrounding this charge. So this charge will actually attract other charges. There will be a force between those charges, but oppositely charges. So we are having this chlorine in this side also, chlorine in this side also. That means it's having 6 chlorines at different angles. ठीक है बेटा? तो इस एक्सिस में इसके 2 क्लोरीन होंगे, यहाँ पे क्लोरीन जिन पे ये इम्पैक्ट करेगा, where it can have impact. So this indicates, this dot line indicates that they are lying out of the plane of this board. It's like this. So this is sodium, the chlorine will be here, and other chlorine will be on the other side of the board. So how many chlorines at the simultaneous? It's having effect on the different chlorine atoms at the simultaneous time. Okay, dear. Simultaneously, it's having the effect on these chlorine atoms. Now, this makes a regular fashion. So this occurs in a regular fashion. ये सब कैसे हो रहा है? ये ऐसे वैसे नहीं हो रहा है, बड़े बड़े अच्छे तरीके से हो रहा है, in a beautiful fashion, in a beautiful manner, so that it is forming a structure. That structure is known as lattice. Okay, dear. So the structure which is formed, that is known as lattice. So if you see these compounds, they are like this. They're in a regular fashion. You can find the attraction in them. So we mention them as lattice. इनको हम lattice बोलते हैं, ठीक है बेटा? जैसे इधर और होंगे पीछे की तरफ से, तो इनमें attraction होगी. So we call them as, this structure is known as lattice, and this lattice makes them a crystalline solid. Okay, dear? The lattice structure makes them crystalline. Not only sodium will have impact on the chlorine, but this chlorine, negative chlorine, will have impact on the sodium, like this. Okay, making here. So what we study, that this fashion is making a lattice. So I will draw here lattice of the chlorine also. That is negative. It will have impact on the sodium. That is electrostatic force on sodium. Here sodium. So here it will be sodium. Okay, dear. So here it will be sodium. And out of the plan, which I can't draw correctly here, that is like this, sodium, and like this, sodium. Okay, dear. So it's forming a regular fashion, and that regular fashion we term as lattice. So this lattice helps to make these substances crystalline in nature. So they are in the form of crystals. Although we have already studied, they are hard, they are solid, they are hard. Their hardness is measured in terms of brittlety. If we just try to break them, they will break, or they will broke with the regular phases. अगर आप say you are having the salt NaCl, okay dear, and that salt which is made from the salt of the sea, okay dear, if you are having in the form of balls, you will see that will be having a regular fashion. उनमें plain surfaces होंगे, you will find the plain surfaces, and this indicates that these substances are crystalline in nature. Okay, now we'll take another property, that is their melting and boiling points. The third property is they are having high melting and boiling point. Okay, we're talking about the ionic compounds. They are crystalline, they are solids, they are ionic. Now we take another property that they are having high melting and boiling point. Why high melting and boiling point? As already we know that they are made up of ions, and those ions are having greater forces. Okay, they're exerting electrostatic force on other ions. Because of this electrostatic force, these are held together strongly. Because of greater force between the ions, we need high energy to make them melt or to make them boil. Okay, so we need high energy. We need high energy to make them melt or to make them boil. That's why we say that they are having high melting and boiling points. The reason behind is that they are actually made up of ions, and there is greater force between the ions, and those forces require high energy to break them. And that's why they are having high melting and boiling points. Now we will take another property of these ionic compounds. So these are actually their solubility now. These ions are the ionic compounds. They are soluble in polar solvents. Okay, now I have written here, they are soluble in polar solvents like water. You know, water is a polar solvent. This like this, one of negative, one of the positives, one of the positives. So it's a polar solvent. So these ionic compounds are soluble in the polar solvents, and they are insoluble in non-polar solvents. So we'll write here insoluble in non-polar solvents. They are insoluble in non-polar solvents. Like if we take alcohol, that's a non-polar solvent. If we take this benzene, that's a non-polar solvent. Or we take ether, that's also a non-polar solvent. And these ionic substances or ionic compounds, they are insoluble in non-polar solvents, but they are soluble in the polar solvents. Now we will take another property, that is conductivity, about the conductivity. So conductivity. What does conductivity means? Conductivity means ability to conduct. Next. Now, the conductivity is ability to conduct electricity. So if we take these ionic compounds, Do they conduct electricity? Yes. But in which state? When they will do this? Number one, we take their solid. So
Solid.
their solids will never conduct electricity. Their solids will never conduct electricity. Why? Because they are strongly having force between their ions. Okay, dear.
Yes, sir.
Strong force between the ions. So the two ions will not be free. They will be attached. Now, if we make a solution, okay, dear, if we make their solution, say solution of sodium chloride, or we make them in a state where they melt, or we can take their melted state. In the melted state, the force of attraction between decrease it. The force of attraction between the ions is decreasing. Means the ions are free. They can freely move. Okay. When we make a solution, they can freely move. Now, in this state, that is in the solution state or in the molten state, their ions are free. They can conduct electricity. So we can write in solution form. Molten state. They conduct electricity. Okay, dear. So in the molten state or in the solution state, they can conduct electricity. The cause behind is that in these two states, their ions are free. They can freely move. As you know, ion contains charge, and these charges, when move, conduct electricity. That's all about